All right, let's take a look at your homework here. See if you have any questions. So when we take our quiz on graphing, and there'll be some other things on there too, you're going to have to draw some by hand and not necessarily with graph papers, which is fine. Because we talked yesterday or talked Friday about the marks that you make, kind of depending on the period of the function. So that's kind of the key to that. So sometimes actually graph paper almost gets in the way a little bit. I mean, it can be good, but I mean, you'd have to put marks where you want them and so forth. Kind of like mine here. I got the black marks and I got the blue marks. The black marks 1, 2, 3, 4, 5, 6, but yet for the sine curve, we'd like to have pi and pi halves and 2 pi, and those are kind of in between there, So it's almost be better if the black marks weren't even in there, and I just went with the blue marks. Because sine and cosine, you always want to think about these 5 points. Each cycle will have, 5 points if you count the beginning and the end. Okay, so start, and then of course the ending should always come back to where it started. That's one cycle, because that's what we mean by periodic. It repeats. That segment of the curve will just repeat over and over and over again. Okay, we talked about amplitude, and we talked about the period, talked about domain and range, how sine and cosine are always between -1 and 1. Of course, unless you stretch them and stuff like that, then that changes that. But the domain's always going to be all reals, and the range of the normal sine and cosine curve is -1 to 1. Okay, so you have to do some graphing. You'll have some graphs, and you have to write the equation, and then maybe kind of some matching. You have to match some graphs with the equation. So that's the main thing on the quiz. Now, we're also going to do some stuff on your Chromebooks a little bit today. I'd show you how you can, check answers. You can type, with graphing calculators. We'll use Desmos, but you may go to a college class, or I know in calculus, we use a graphing calculator a lot. And I'm sure they'll continue to do that next year, and colleges will a lot too. Okay, and so being able to put graphs into a calculator and set your X, min, and max, your window, and so forth, we're going to do that in Desmos for this class pretty much. But so we'll talk about that. Now that part's not really going to be on the quizzes, but it is something that's important to do. Okay, so, and of course sine curve starts down here at the origin, goes up, right? Cosine curve starts at a 1, goes down like that. And of course that goes back to what we did. That goes back to what we did here, right? If we're doing the sine curve, and this is that connection. I want to talk about that here at the beginning a little bit again this week. The sine is the y on the unit circle. So that's this blue segment. The red is the angle. So what we're doing down here is we're graphing. So we're kind of switching it around. So here, the x and the y are different than the x and the y here, right? Just so everybody understands it. Okay, the x and the y on this graph is different than the x and the y on this graph. Here, the x coordinate is the cosine of the angle that's formed by this point right here. Okay, the y on the unit circle is the sine of the angle. So we have both cosine and sine on the unit circle. Okay, here the x and the y is different. Here the x is the angle, right? Here the x is the theta. And then the y is either the sine or the cosine, depending which one you want to graph. Now, right now I'm graphing sine. So the y coordinate here is the sine, which I guess is kind of like this. That's why you see this blue bar kind of going up just like it does here. The red is down here on my x-axis. Okay, so as that goes around, those y values on the unit circle are the y values here, but as we plot the red going that way, okay? And then if we change that to cosine, we can see why cosine starts up here at 1, because down here at 0 angle, the cosine is 1. But now we're graphing this green, we're graphing the x from this graph, right, from the unit circle, we're graphing that as the y on this graph. So this is the cosine graph, so the y is cosine, and again the x is the angle. Okay, so our x is theta. And the green's getting smaller and smaller, and now the green is negative and getting bigger, and now it's still negative but getting smaller, so it's coming back towards 0, and now it's bigger and positive. Okay, so that's that connection. We always want to be able to understand And so now we're going to be able to use the graphs and the unit circle kind of in combination. We're going to talk about that here in a minute. But any question on the homework? Any of those you want to see? We had to name the amplitude, name the period on some of them. And then did you have to sketch some? You had to sketch some too, right? Were there any of those that you wanted to see, the sketch?
Like when the period is at 1 or 2.
Without pi in there?
Yeah.
So give me an example of one.
Um,
Somebody help her out. Is there one there that...
Like number 45. I just got that.
45? Yeah. So you got y equals cosine 2 pi x. Yes, let's talk about that because that is really important. So the formula for period, now we're going to kind of go in reverse here in a minute, but the formula basically is period. You take the old period, which for sine and cosine is 2 pi, and divide by b, that number that's on the inside, the 2 pi. Okay? Now, likewise, we can multiply the b over here, divide by period, and this is something we're going to talk about here in a few minutes, is what if I give you the graph and want you to write the equation, right? So then you look at the graph, so you would look at the period, so you would know the period, and then you just take 2 pi divided by the period, and that gives you the b. So it works the same way, no matter what. So if you know the equation, you know the b, you can figure the period. If you know the graph, you know the period, you can figure out what b must have been, right? So anyway, we take 2 pi divided by 2 pi here, which is 1. So the period's going to be 1. So when I want to graph that, and this is what I kind of was talking about right at the end of class, and you're right, it was a Friday, but it was a really important concept that is worth repeating here, so I'm glad you asked that question. Every sine and cosine curve, 1, 2, 3, 4, 5 points, right? Intercept, the minimum, intercept, maximum. Same thing here. Intercept, x-intercept, right? It's on the x-axis, maximum, back to the axis, minimum, back to the axis. Always going to do that, okay? So what I need is my starting, and then 1, 2, 3, 4 points. I always need 4 points. That represents the 4 quadrants. So if my period is 1, I'm going to need 4 marks. And what goes here? 1 goes there. Okay, so that's a period. Now the way I always do it is this way. I always do that, then I take half of that, whatever that is, and then I always take half of that because that's this mark and that's this, and then I just count. So, okay, if this is 1/4, then this is 2/4, then this is 3/4, right? A lot of fraction work here. There's going to be a lot of fraction you're going to see we're going to get into today that are important when we do this graphing, especially when we get into some of the more tricky ones. They're tricky because they involve fractions. If you can handle the fractions, shouldn't be a problem. 1/4, 2/4, 3/4, 4/4, right? Just like that, okay? And then nothing else has changed, so the amplitude is still 1, so this is going to be -1 and 1. And now once we have that, now we just have to say, okay, I want cosine. Cosine starts here, going to come down to here, then going to come to here, going to come to here, and then going to come back up to here. And then make sure you curve it a little bit so it's not just a V. Okay, like so. All right. So you could argue that you could have a page full of these that are all different, and yet they would all look exactly alike. What would be different, right? This could be 8, 16, 24, and 32. You know, that's a lot different graph than 1/4, 1/2, 3/4, and 1. But if you had one that was a period of 32, that's how you would mark those different parts, right? And if the amplitude was 7, then you would change these to 7s, and there you go. I got a totally different graph, okay? But it looks exactly the same, so they're not to scale. You would have to go to a calculator or something like on Desmos here. Okay, here I've got a whole bunch of different ones that we're going to look at in a little bit, right? I mean, they're all vastly different because the difference here is they're all sine. Well, no, there's some are sine, some are cosine, but they just have different. But the scale's the same for every one of them, so they look vastly different. But if I took each one individually, and we're going to do that actually, if I took each one individually and changed the window that you're looking at, they would then look all the same. Okay, so the markings are the key, right? The scale markings that you put on your picture are the key to these problems. Okay. All right. Which one? 49. I was going to say. I think I'm doing that one. Doing that one today. What do you want to start? Yeah, we stopped at 47. Right? Okay, any others? Yes.
We do 47.
Do 47, sure. Code, so y equals, read it to me, negative sine 2 pi x over 3, is that what it said?
I think that's right.
Yeah. 2 pi x over 3. So remember that x can just be, and I usually do, but the book doesn't always. I usually stick that down in front like that. Okay, so the b is the 2 pi thirds. The b does not include the x, right? So our period is going to be 2 pi divided by 2 pi thirds. We're going to invert that and multiply like so. That's going to cancel those, and we're going to get a period of 3. So the period's going to equal 3, right? So it's 2 pi over 1, and then we invert that, right? We divide by 2 pi thirds. That's the same as multiplying by 3 over 2 pi. Right? So we get a period of 3. So when I go to graph it, now I should pay more attention here. It said include 2 full periods. Okay? It said include 2 full periods. So I don't care if you just stay on the positive. Let's do that. So let's say here's going to be my 4 marks that I need, right? Including my one back here. This is sine, okay? The amplitude is still 1 and negative 1, so I have to worry about that. So I'm going to go, so what's my period? 3. Now, I don't care if you use decimal or fraction. I don't want rounded decimals. If it's like thirds or 6, okay, then we should use decimals. But since these are going to be actually not bad, you know, you could go here like this. So this is 0.75, 1.5. This would be 2.25. You could do that, okay? I'm probably not going to get real picky with that. I don't know, I might change my mind, though, to be honest with you. You know, typically if it starts as a fraction, it's best to leave it as a fraction. You know, we're doing so much work with fractions, it's probably not a bad thing to do that. So how do you do that? I would say that, right? To take half of a fraction, what do? You double the bottom number. You double the bottom number, right? Because when you take half, if you have some fraction, a over b, and you take it times a half, what happens? The bottom number is times 2. So if you got 3/4, half of that is 3/8. Right? Now, I might reduce then, okay? So to take half a fraction is really easy. You just double the bottom number. So I got 3 over 1, so this would be 3 over 2. This would be 3 over 4, right? So this is 3/4, and so then I would count, just like we counted around the unit circle. Now, that means every mark. So once you do that, so you go 3 here, half of that's 3/2, half of that's 3/4, just double the bottom number. Once you find that first mark, every mark is 3/4. So 3/4, 6/4, 9/4, right? So it's not that hard to do, and this would be 12/4, which of course is 3, okay? And now it's negative, so instead of going up, it goes down. It's a vertical flip. So it's going to go here, down to here, to there, up to here, and back to there. Like so. Okay, so that's what you need. You need to have that. Now, it's supposed to be 2 full periods. Okay, so 1, 2, 3, 4 more marks. And now, but since we know this is 3/4 every one of these, the next one we said this was 12/4. This is going to be 15/4. This is going to be, that doesn't reduce. 18/4 would reduce, so that's 9/2. 21/4 doesn't reduce. And then 24/4 would be 6, and that makes sense that would be 1 more period. Okay, so once you know this first mark, you can just count by those. 3/4, 6/4, 9/4, 12/4, 15/4, 18/4, 21/4, 24/4. You're just adding by 3 on the top number. but you should reduce them. Okay? Now, I would guess you will be allowed to use your TI-30s, on this, so you can let the calculator help you adding the fractions. But to be honest, that takes more time than just if you practice it a little bit than just do it in your head. So now you get 2 full periods. Okay, if you want to go backwards here, then all you have to do is make these numbers negative, right? Then it's not maybe as big a deal. So you can just go, this would be negative 3/4, negative 3/2, negative 9/4, negative 3, and do another period back that way. That's fine too. Okay? All right, anything else? So that's the basic graphing if we squeeze it and change the period. The horizontal movement's the hard one. Today we're going to talk about shifting. Vertical's not too big a deal, just shifting up and down. Stretching, amplitude's not a big deal really. We start moving horizontal. We compress horizontal, it changes these markings. When we shift, that gets kind of tricky too, because depending what your markings are, how far do you shift? Okay, so we're going to talk a lot about that today. Okay, see if you could do this real quick. Write the equation that would be described by these two right here. Write the equation that would be described with this.
Good morning, and pardon the interruption. I have one weather-related cancellation. The JV Wrestling Invitational scheduled for this afternoon at Grand Island Northwest High School has been canceled. Once again, the JV Wrestling Invitational scheduled for this afternoon at Grand Island Northwest High School has been canceled. Thank you.
Okay, I bet you're so happy you could just scream right now.
All right, what do you get for the first one?
3 cosine 2x.
3 cosine 2x. Okay, what about the last one? Negative 3/4
Sine.
Negative 3/4 sine 12x. Okay, so like I was saying a minute ago, 2 pi. Now that's the normal period. That's why we do 2 pi. What you'll learn when we learn about the tangent function is it has a period of pi. It repeats every pi unit. So for tangent, we would take pi divided by. Okay? But for sine and cosine, it's 2 pi. So 2 pi divided by b gives you the period. 2 pi divided by the period gives you b. It works both ways. So 2 pi divided by a period of pi gives you 2. So there must have been a 2 here. And then 3 goes there. So 2 pi divided by pi 6 would be 2 pi times 6 over pi. The pi's a cancel, you get 12. The 3/4 is the amplitude. Notice I didn't say the amplitude was negative 3/4. We always say positive for amplitude. The negative is a flip. Okay, so the amplitude is always just the distance above and below the middle. So it's going to go up to 3/4 and it's going to go down 3/4 from the middle. Okay, and so that's the amplitude. So we don't want a negative on that. Okay, but the reflection, of course, means there does have to be, and again, if it's over the x-axis, you're flipping vertically. So that's why the negative has to be there. Okay, all right. Of course, remember we talked about even odd functions. I mean, go back to this. What happens if you flip this one horizontally? It just lands right on top of itself, doesn't it? Well, that's because cosine x and cosine negative x are the same thing. It's an even function. That's what we talked about. The definition of an even function was opposites in, you get the same thing out. So if you do a horizontal flip, it lands right on top of itself. It's the same thing. Well, what about sine? What happens if you do a vertical flip on that one? Not a vertical. If you do a vertical flip, it's opposite. But what happens if you put in a negative x here? You actually get, we said it was opposite out, opposites in, opposites out. So what happens if you flip this vertically? You end up getting, you flip it vertically is the same thing as the opposite of sine, not the same thing. Okay, what's that? Yeah.
Actually, it's a dashed line.
But notice if you flip this, if you took the blue and flipped it horizontally, that's the same as flipping it vertically, right? If you take the blue here and flip this horizontally, it's going to land on top of the red one, which we got by flipping vertically, right? So a vertical or horizontal flip is essentially the same thing when it comes to sine. That's because that's a property of an odd function, okay? All right, so good. All right, let's take a look at number 1 here. I don't know if we'll do all of these. Okay. So sketch a quick graph at number 1 there. Write down the amplitude, the period, because I don't know when you guys did this homework. Maybe you did it late last night, so this is all very familiar. Maybe not. Maybe you did it first block or something, second block. Yeah. So it's really familiar. Okay. Then we can quit wasting time with all these warm-ups. Just try to sketch a quick graph of that, write down the amplitude and period. And do that one. Then while you're at it, let's do 2 real quick, and then we'll move on. Sometimes we see theta in these, but usually when we're talking about graphing them, when we're talking about sine and cosine as functions, a lot of times we switch that and use x as our input because we're kind of used to that. Of course, we're talking about the unit circle, we kind of have to use theta, right? Because x and y are different. We showed that earlier with that picture. The x and y are different when you're in the unit circle. Okay, x and y are the points around the circle, and theta is the angle, so that's different. All right. Okay, what are you getting for the period on the first one? Period is pi. Okay, I'll give you a little time yet on the second one here, but that's what I got for the first one. So pi, half of that's pi halves, half of that is pi fourths. So each mark is 1 pi fourth, 2 pi, then 2 pi fourths, 3 pi fourths, 4 pi fourths. That's just one period I graphed there, and then you can always do another one, whatever the directions say. Amplitude of 3, but it's got a negative, so it's got a vertical flip, so it has to start down below. Now on the amplitude, I could have put just one mark and called it 3, and then the mark down below -3. I don't have to put all 3 of those marks here necessarily. You just have to have it labeled properly. We're just going to do 1 and 2. Don't worry about it. So what's your period on number 2 then? 8 pi, right? It's 2 pi divided by 1/4. So this theta over 4, I'm typically going to think of that as 1/4 theta. It's a good habit to get into because it's one of the first things I tell my calculus classes is most calculus rules that we deal with things like this, having it as 1/4 theta is much more user-friendly than thinking theta over 4. Now, it's quicker to write theta over 4, so it's okay. Not a problem, but to think of it as 1/4 theta is usually a better way to think of it. So 2 pi divided by 1/4. So we're looking at 8 pi. So the middle mark will be 4 pi. This mark will be 2 pi. So each mark is 2 pi. 2 pi, 4 pi, 6 pi. And then again, I just made one mark of 2/3 and negative 2/3 for my amplitude. And then it's just a basic cosine curve from there. Okay? All right. So really going to spend multiple days on sine and cosine because those two are the graphs that we really have to have down. And to be honest, everything else, all the other 6 trig functions are, come from sine and cosine anyway. All right. So let's skip through a couple of these. Okay. So I'm going to have you do something here. So we can just look at this. You don't have to jot it down necessarily. This isn't going to come up a whole lot. Something you notice here, what's different about my graph, my sine graph here? Degrees. We almost never graph the sine graph and cosine graph and put degrees along here because it's very limiting in how useful that graph is. You're going to see here, we're going to do, tomorrow more, some kind of story problems where, some real life situations that represented by a sine graph. They're these repeating, kind of oscillating kinds of things, okay? And none of those involve degrees. They involve real numbers, okay? And so that's why radian, again, another reason that radian measure is more useful. We haven't talked about angular and linear velocity. Those formulas are way easier and make a lot more sense. Well, some of you may not think they make sense, but they're a lot easier than they would have been in degrees. If we were doing them in degrees, they would have made less sense. So radian is more useful and easier to work with there and in graphing. But we could put it on there. Okay, we could put it on there. So let's say you were just, I wanted you to make an estimate, the best estimate you could of the sine of 165 degrees. So let's first do it on the unit circle. So where's 165 degrees? Second quadrant, where at? Up here? No, kind of down here, pretty low, right? Pretty low down here. Now, what's the sine? What's the sine here on the unit circle? There's 165 degrees. So what am I looking at here to get the sine of that? Well, it's not one we memorized.
I know, but it's just half one.
It's not half. It's not a linear relationship. I know what you're thinking. You're thinking if there was the 30 right here, the 1/2. But where are you getting the 1/2? That's you guys you're overthinking it. On this point right here, where's the sine of that 165 degrees? On the unit circle. What is sine on the unit circle? The y-coordinate. Yes. The y-coordinate, right? So the sine of 165 is the y-coordinate of that point. Now you guessed 1/4, right? And you did that because 150 degrees would be here, would be a 30-degree reference, and that's 1/2, right? So you're thinking that's 15 more degrees. It's halfway down, so maybe it'd be about half. Well, I think that's a reasonable guess. It's not exactly that, but that to me is a reasonable guess. 0.25, right? 0.3, somewhere in there would be a reasonable guess, right? And you would get it because on the unit circle, that's what we're talking about. We're talking about that distance right there because sine is the y. What would the cosine be? Just guessing, roughly. What's the cosine of 165, you think? Just guessing on the unit circle there. Negative 0.9, 0.8. It's almost, remember, this is negative 1 out here, right? The cosine is the x, so about negative 0.8. Okay? All right. Now let's go over to the sine curve itself. And could we estimate sine of 165 degrees? Sure. Where's 165? Up there. And here we're looking for the output of that. What do you think? About 0.3 maybe. It's definitely not halfway up. But again, I go back to this picture, right? I go back to this picture. On the unit circle, let's do cosine. Okay, let's get it over to here. No, we're doing sine, aren't we? We're doing sine. Okay? So let's get over here to about 165 degrees, about there. Okay? Right? We're doing sine. We're interested in this distance right here, about 0.3. I don't know if that's even on here somewhere. Oh, look at that, right there, 0.3. Okay? Over here, we're looking at what? We're looking at that distance right there. Okay? Now, we were also trying to do cosine of that one. Let's hide the sine. Okay, what's the cosine of that? Yeah, about 0.8, 0.9, negative, right? What is it here? It'd be this distance, right? Because this is our 195 degrees, or excuse me, 165. Here's our 165 degrees, and then you'd have that value. See, the points on this graph are different than the points on this graph, right? The points on this, the point here is the sine and the cosine. This would be about negative 0.9 and about 0.3. That's the cosine, that's the sine. The point on this graph is what? What's the first coordinate? What's the first coordinate? What's the first coordinate here? No. What's the first coordinate of this point? It's the x coordinate. It's this. What is that? Let's go to degrees. It's the problem we're doing. How many degrees? Yeah. The coordinates of this point is 106. Now you're right. In this picture, it's in radians. It's in radians. I get it. So you're saying about 2.8. Okay, if you're saying 2.8, right? That's radians, but we're in degrees right now, right? The problem we're doing is in degrees. So it's 165, and then this value right here is about negative 0.9, right? So it's that value right there, the cosine value, right? The sine value is nowhere to be found here. Why? Because this is the cosine graph, right? This is the cosine graph. Now, if I want to put the sine graph on here too, I can't do it because I'm in this over mode, but okay? So that's what I'm talking about. The points on this graph are different than the points on this graph. The points on the unit circle is the cosine value and the sine value, both. The points on this circle are the angle and then the cosine value, right? The angle and then the cosine value, right? They're both functions, right? Because they have an input and an output. Well, this isn't a function, vertical line just because you repeat, but okay? All right, so back to this. Okay? So estimating sine of 165, this is the point 165 degrees and about 0.3. This is right here, we said this is about negative 0.9 and 0.3. So what's the sine of 165 on the unit circle? It's the y value, 0.3. Here on this graph, it's the output when you put in 165 degrees, about 0.3. On your calculator, what's sine of 165 degrees? Have you done it yet? Do sine of 165 degrees. Point 3, 0.25 something. 259, so it's close to 1/4, like the x-tip it is. But that's the idea. Okay, that's really important that we not just memorize. Memorizing is okay for a lot of stuff we do, but like the unit circle and stuff, we gotta understand where it's coming from and understand the concepts behind it too. Okay, do this real quick then. Do a matching. Okay, do a matching. I just put the cosine curve up there. I got degrees across. So cosine of 35 degrees. Which one of those is its value? A, B, C, or D? A, B, C, D, or E? Do a quick matching. 1, 2, 3, 4, 5. Put the letter that goes with it. You don't have to write all that down. Just put 1 and then the letter. 2, then the letter. 3, then the letter. Okay? There you go. Get them? Okay. So notice all those values on the right are between -1 and 1, right? All those values on the right are between -1 and 1. Okay? So one of the things we always want to understand about the sine and the cosine functions is that we put an angle in, right? Now that could be radians or degrees, and we get what I call a value out. Now it's kind of weird to call that a value because any number's a value. 90 degrees could be considered a value, the value of that angle. But I want to think of that the value of the function, and that has to be between -1 and 1. Okay? And the angle can be anything, right? That can be all reals. I mean, that could be anything. So we can plug anything into there. So we're always doing the cosine of an angle. That could just be two radians, right? That'd be 2 of those strings going around, right? So it could just be a number, but it could be any number. It represents an angle, okay, in radians or possibly degrees. But you'll always get out some value between -1 and 1, okay? We can see that from here, and we can see it from the unit circle. All right, so let's go back to your notes then. Let's go ahead and get your notes out here, and let's talk about our shifting. Man, this goes fast. Does it go fast for you? Don't answer that. Don't answer that. Or just smile and say, yes, it goes really fast. Yeah. So excited. All right. So what we were talking about there were non-rigid transformations, things that change the shape of the graph. I mean, the basic wave pattern's still the same, but they stretch it and compress it. Okay, non-rigid transformations is what A and B do. So the amplitude, the period, the A and the B do that. So the C and the D are what we call rigid transformations, which is, and we did this in chapter 1, but this is just your shifting. So when it's on the outside, like the D, that's an up and down shift. Outside affects the outputs. So the D is up and down. And the C is left, right. Now with trig functions, that's often called a phase shift. Now I usually say horizontal shift because that's the term we use with all functions. But for trig functions, like for example that amplitude, most functions would call that a vertical stretch or shrink. But because you have this high-low on the sine and cosine curves, that's got kind of a special name called amplitude. But it's really a vertical stretch or shrink. Okay, same thing here. You got a left-right shift, but that's sometimes called a phase shift with trig functions, but you just call them. But so if you see that, if you hear that in the directions, understand what they're talking about for a phase shift, left-right. Okay, so how do we make that? How do we make those happen? Right now, notice the B is pulled out of the inside there. The B, if you're going to have both a horizontal stretch or shrink, a period change, and you're going to be shifting it, the B has to be factored out of there. So there's no number in front of the X in here. It's got to be a 1, which means this will be a fraction a lot of the times, it's C. Okay? All right. So let me show you some examples here. Let me show you a vertical shift, first of all. Just a quick, okay, so here's a vertical shift of 4, okay? So I just take it, so the thing we have to do, notice the dashed line there. I almost said that. See the dashed line there? That's sometimes good to put in. If you take this graph and lift it or lower it, it's good to know where that middle is, what used to be our axis, because remember, when we graph this, those are important points right there in the middle. Okay, so those points are shifted up 4, so it's good to put that midline. And then again, your amplitude, so if your amplitude is 2, that means you go 2 above that and 2 below that. Okay, that midline. So that's often a good thing to do. Notice they wrote new origin when they did that. Now, when we go this way, we don't have to worry about it. Now, they do that on here. Now, I went ahead and did a little bit of Desmos. Now, later, you guys are going to get this out on Desmos and look at it. So Desmos works really cool too. I just typed in y equals a times sine, just like I had, and it asked me right away, as soon as I put in an a and a b, it said add a slider, and I just said yes, clicked it, and then it just puts a slider in here. So now I can change all those. So I'm going to change the amplitude, right? And there's the, of course we've been doing that, so I'm not going to mess with that much. You want to change the period, so you want to change that to a 2. Okay, so now the period is, right, pi, here's 3.14 right there, and I can change those units, and we'll do that later after lunch. Change those units so they're in terms of pi, but I want to leave that here. Okay, so now let's talk about that vertical shift. So if I want to shift it up, right, shift it up 3, here's that midline. I would probably draw that in there at 3, okay, and if you go down 3, okay, so those are pretty easy shifts to do. This is where it gets a little tricky, okay? Where do those things going to land? Now, what I did is put pi eighths here, I think. That's pi eighths, that's pi fourths, that's 3 pi eighths, that's pi halves, okay? And so I set it to go, there's a shift of pi, okay? Now, look what happens. What does that graph look like to you? If you just were looking at that, what would you think that is? Wouldn't you think that's negative sine? Well, guess what? Because it still has a period of 2 pi. It's still got the normal period. There's 6.28 right there. So what did I just do? I shifted it to the right pi. Wouldn't that be this? Right? Those two are equal. Doesn't it make sense that if you shift horizontally, eventually it'll land right on top of itself, kind of, right? I mean, let me, oh shoot, I thought I had that on here. For example, if I put a new one here and I typed in, let's just put in the normal sine curve, okay? There's a normal sine curve. Now what would happen if I shifted the red one to the right? Let's move it back. What would happen if I shift the red one 2 pi to the right? Shouldn't it land right on top of itself, right? If you move it one whole period, well, that's actually the definition of period. I don't know if you guys remember that, but when we defined back in chapter 1, we said the definition of a periodic function is this, right? That not f of p, that'd be f of x. So that, in other words, if you shift plus or minus p, if you shift left or right, because that's what x plus p is a shift this way, if you shift one whole period, either left or right, the graph's just going to land right back on top of itself, right? So sine of x plus 2 pi or x minus 2 pi is going to be exactly the same graph as sine, the original sine graph. Okay, so you can do this yourself too and put that in Desmos and you can play around with those, and it's pretty kind of cool. All right, so let's take a look at one here, one or two real quick before lunch. So before we get done here, I can maybe give you some work time. So let's say you have this. So on your paper here, just in your notes, write down this graph right here. So this would be what would be kind of an easier one to graph, and it would be easier because the markings and the shifts are all going to be the same as the original. So this has an amplitude of 1, but it's been shifted to the right 3 pi halves, and it'll be shifted up 1, right? So sometimes we put the normal cosine curve in. So is the period going to change at all? Period's not changing, amplitude's not changing. So we can go ahead and put our 2 pi right there, and our pi right there, and our pi halves. So since the period's not changing, that's nice. Okay? And so sometimes what I like to do is take my points for my normal graph and go ahead and put them in. Now, if I would have had an amplitude right now, like a 2, I probably would have put this top point up here at 2, put this one down here at 2. But now I'm getting ready to shift them. Okay, so the period and amplitude, a lot of times I'll take that into account. That's what we've already been working on, so that's the easy part. Okay, so if there was an amplitude, if there was a period change, I would have put the period change in by changing these marks, right? If my period was going to be pi, I would have went pi halves, pi fourths, right? I would have change my markings. And then my amplitude, I just would have had this point up high. Now I'm getting ready to shift it. Okay? So I'm going to shift it to the right 3 pi halves. Now I'm going to change colors, but I'm going to go to the right 3 pi halves. Now why is that easy? Because I have markings for 3 pi halves. How many marks is 3 pi halves? 3 marks. So that means this graph is going to go to the right 3 marks. So every point needs to go to the right 1, 2, 3. This point's going to go 1, 2, 3. This point here is going to go 1, 2, 3. This point's going to go 1, 2, 3. And this last point's going to go 1, 2, 3. Right? Now I'm going to dash that because I'm not quite done yet. What do I got to do yet? I got to go up 1. So if I was you guys, I'd probably be doing it in pencil, kind of lightly, and then maybe when I get the final graph, erase, you know, what I had, or just do, you could leave it actually, as long as your final graph's nice and dark and I know what's what. So now we got to go up 1. So every point just has to go up 1. Right? So every point just goes up 1. And now we got this graph here in our midline, you know, midline through here. You don't have to draw it, right? But that would go through like so. So there it is. Okay? So you can kind of put in those original, so you can take care of the amplitude and period first, which is why we studied it first. Okay? And then 3 pi halves, that's nice because I've got marks. 3 pi halves is 3 marks. So I'm just going to move everything over to the right 3 marks. Where this gets weird is what if the shift would have been pi fourths? I don't have marks for pi fourths. Okay, well, it turns out pi fourths would be half a mark, right? So after lunch, we'll talk about how to deal with that. Okay, so we'll remark it for that.
Of course.
Let's get through this as quick as we can and hopefully get some work time here. So the main thing, so it's easy with a tool like this to just see what happens. And one of the things that you will be asked to do too will be to describe. We'll look at some in the book where you just describe, they give you sine x and then sine x minus pi half. Describe what happens. It's kind of like the first quiz, one of the first quiz we took. You gotta do, well, the second graph is just a phase shift or a horizontal shift, pi half to the right. So be able to describe it, whatever. But when you see it, so you say, okay, B, that's going to change the period, right? So yeah, it's going to do that. But finding those exact marks and stuff is the part that we need to really, that we'll be working a lot on. Or shift, now the shifts are pretty easy to find the marks, although the horizontal shift's a little harder, again, because of what are those marks? And that's what we want to talk about right now. So let's go ahead and go to this problem right here. Okay, now don't just write the problem down in your notes. Don't write down my markings, everything. Put a grid, just put an XY axis maybe. And I put some marks on it, but I think we're going to need more. And so let me show you here. I'm probably going to end up erasing. I'm just going to do it right now. So I put on pi halves, 3 pi halves, let me end. But just to show you what you may do if you don't think it through, then you end up having to erase stuff. And so I kind of want to show you what it would look like. At what point you'd realize, oh, shoot, I probably should rethink this, okay? So I look at this graph, and so I got the 1/2. So what's that going to do? What's the 1/2 going to do? Amplitude. So it's only going to go up 1/2 and down 1/2, right? So this first mark I could just make be 1/2. Right, and negative 1/2. All right, and this is just going to take the whole thing, shift it down 1, which we always can do that at the very end. Right, that's usually the last thing we would do. Okay, so this is going to do what? Right? By pi thirds. So there's the problem, because the period isn't going to change. So if I took my normal sine curve here, and I took this point, and I took this point, and this point, and this point, and this point, let's say I made that 1/2, that'd be fine. And negative 1/2. Okay, now I've got to shift those to the right by pi thirds, but where is pi thirds? I mean, if this is pi, then pi thirds would be like right in there. I would have to divide, I'd have to pretend this mark wasn't there and just divide that into thirds, right? So that'd be easy to shift this pi thirds, right? And I could do that with each one of these marks. This would be 3 pi thirds, and then I'd have no, but then the problem becomes, well, what about this point that's at pi halves? Where does that point end up? Where does pi halves end up if you go to the right pi thirds? What's pi halves plus pi thirds? Can you do that in your head? Yeah, I think you're right. 5 pi 6, because pi thirds would be 2 pi 6, and pi halves would be 3 pi 6. Add those together, that's 5 pi 6. Well, that's not one of these red marks. This would be pi thirds, this would be 2 pi thirds. 5 pi 6 would be right here. You see what I mean? And so all of a sudden it gets kind of complicated finding exactly where to go with those marks, and it's not going to be good enough to just say, it'd be about here. Right? I mean, we're going to do better than that. Okay? So, here's what I would suggest when you notice that that's happening, that you've got to shift it pi thirds, is I would suggest something like this. So, okay, I know I've got so it's okay to put these markings down first, right? Because that's the period. These are important, right? Because that's the period. So you're going to want those marks spread out like that, okay? So what that tells me is that one mark is pi halves. So I'm going to jot this down. Normally I wouldn't write this all down, but one mark is going to be pi halves. That's what I want it to be. Okay, I want one mark to be pi halves for my 5 important points that I have to put on my sine curve. Okay, but then I have to shift it pi thirds. Well, I put those two together, get a common denominator, and that's what I should mark my axis in. So I've got pi halves, and I've got pi thirds, common denominator is 6, so I should mark this in pi 6, and that will give me the marks I need to move, and everything will be good. Okay, so Now remember, we got a period of what on this one? What's the period on this one? 2 pi. So if I'm going to do one full cycle, I got to do 2 pi. If I'm marking it in 6, how many markings do I need? I'm going to need 12 of them, right? 12 pi 6 is going to make 2 pi. So I'm going to need 12 markings. So I'm going to need to have more than I had up here. Okay? So I'm going to go 1, 2, 3, 4, 5, 6, 7. That's going to be my 2 pi. Okay? So let me erase these here. Okay? And half of that, 1, 2, 3, 4, 5, 6, that's going to be my pi. That's going to be pi, right? And 1, 2, 3 markings in, that's going to be pi halves. And 1, 2, 3 markings, that's going to be my 3 pi halves right there. So there's my 5 important, beginning, pi halves, pi, 3 pi halves, 2 pi, because of the period. So we always need those markings to be in there because of the period. All right? So that tells me on my original graph, this is before I shift it, because I'm going to do that. I want to do that at the end, but I always like to get a dashed one in there before I shift it, okay? Or at least get the dots in there. So I'm going to have a dot there. If I'm going to call this 1/2 and call that -1/2, I'm going to have a dot there. I'm going to have a dot down there. I'm going to have one there. So I at least want those dots, because then I can shift those. I don't need to put in the dashed line really right now. I mean, I could. Okay, for this sine curve, but really what I need are those 5 dots in the right places with the right markings, and now I can shift. Okay, so now, what is each one of these? And then I always like to mark the very first mark, because that tells you what each mark is worth. And what is that going to be? Pi 6, right? That's what we decided. That's why this is 3 pi 6, 2 pi 6. This is going to be pi 6 right here. So every mark is pi 6. Okay, now what am I supposed to shift it to the right?
2 pi 6.
Pi thirds, which is 2 pi 6. So that's 2 marks, right? So my shift to the right is pi thirds, which is 2 pi 6. Each mark is pi 6, so I'm going to go 2 marks. So change colors here. So this one is going to go 2 marks. This one will go 2 marks. This one will go 2 marks. This one will go 2. That's 1 mark, isn't it? Yeah, I didn't grab it over there. Okay, this would be 2 marks. And then I really need a couple more marks out here. Kind of ran out of room. All right, and then I could dash that if I want to, but I still have to do what with it? Do I have those, or why doesn't that look right? 2, 2, 2. Maybe my marks aren't spread out. This one didn't go far. All right, and so now I got to go down 1. Now remember, this was a half. So it's going to go, this would be -1, this is -1 1/2 or -3 halves, right? So my middle is now actually going to come down to here. So I'm actually coming down 2 marks, so these red marks are all going to come down. So I'm going to have one here. It's got to come down to there. This one's got to come to the middle. This one's got to go down there. This one goes up there. Okay, and then and probably to finish it, especially if I was doing this on a quiz or something, I would probably finish these marks. I might put in here. This is pi thirds. That'd be 2 pi 6, 3 pi 6, 4 pi 6 is 2 pi thirds, 5 pi 6. Right? We said this one, right? We said this one that was a pi halves that shifts over pi thirds should end up at 5 pi 6, and it does. Okay. And so forth. Then I can finish those. Each one of those is pi 6. So it's kind of like going around the unit circle. 6 pi 6, 7 pi 6, 8 pi 6, 9 pi 6, 10 pi 6. And then reduce as you go. So there is going to be a little bit of fraction work on the ones that are a little trickier. Okay? Nice ones are ones where the marks are already there. 3 pi halves, we're going to shift it, or we're going to shift it pi fourths. We already got marks at pi fourths, or whatever the case may be. Then you have to add those extra marks in. So what did I do? I looked at it and I said, okay, what's the period? So let's just review the order we did this. We always look at the amplitude and period first, because those are the easy ones. We just stretch, and then the period is the squeeze or the stretch, and then that determines our 4 important marks. Boom, boom, actually 5, but one's a starting point, so it's really 4. Okay? So once I determined my period was 2 pi, I knew I had to get 2 pi, and then pi halves, and 3 pi halves. I had to get those 4 like we did today. And once I knew I had to get those, then I looked at my shift, and that was pi thirds. I said, okay, they don't match up. So I'm going to need to get a common denominator of 6. That's what I want my marks to be. And since I knew I wanted to go out to 2 pi, and I was going by 6, that's 12 pi 6. So that's what told me I need 12 marks. Each one was pi 6.
So once we get to that last step of like finding that common, will it always be like that?
Yeah.
The stuff that we do, it'll end up being a common denominator.
Absolutely, yeah. And the reason getting a common denominator will do that is because the common denominator, so the pi halves will always land on those because it's a multiple of that, right? And the pi thirds will too. And so by doing the common denominator, that's what makes it happen. That's what makes it happen. Okay? All right, so let's look at this one right here. So on your homework, you're not, I mean, that's not going to happen a lot like that one we just did, okay? It's not going to happen a lot. Now, we're doing a couple. We spent some time doing the harder ones, and then hopefully the other ones will be easy. Now, here's the problem with this one is at 3. Okay? The problem with this one is at 3. Remember back to our notes here? That's got to be factored out off of that x. So this looks like it's a shift of pi halves, but it's not. Okay? So what we have to do is we have to rewrite that. That stays in the parentheses, but then there's another parenthesis now, and it'd be x minus what? It's pi 6. You have to divide. That's what you really do when you factor out. You divide. Think about it. If that was 3x minus 12, when you take out the 3, what do you got left? X minus... If it's 3x minus 12, you take out a 3. You got x minus 4, right? How'd you get to 4? You took 12 divided 3. Whatever you're taking out, you're actually dividing. So if we're dividing by 3, what that does is a 3 on the bottom. So it's pi 6. Okay? So it turns into that. So it's a shift of pi 6, not pi halves. Okay? All right, so our amplitude, of course, is 2. So let's write down a little of the information. What's our period then? 2 pi thirds, right? Now, we've got this horizontal shift, though, of pi 6. So what do we want our mark to be? What's the common denominator with 3 and 6? Oh, 6. So this is actually going to work out just fine. Because watch what happens. When I want 2 pi thirds, so let's say I'm going to go 1, 2, 3, 4 marks, right? So a lot of times you do this and then you erase because you think, oops, I need more. So my 4th mark's going to be 2 pi thirds, right? Right? Once we decide the period, that's that last mark. And then what's the 2nd mark? Got to be half of it. What's half of 2 pi thirds? Okay, yeah, 1 pi third. Yeah, we're making this way too hard. 2 pi, if you have 2 apples, what's half of that? 1 apple. You have 2 pi thirds, half of that's 1 pi third, right? Think of pi thirds as an apple, right? You got 2 pi thirds, you got 2 apples. 1 apple. So half of 2 pi thirds is 1 pi third. Or double the bottom number, 2 pi 6. Right? Half of 2 pi thirds is 2 pi 6. That reduces to pi thirds. Okay? Cheat with your calculator a little bit if you want, but you should feel guilty if you do. All right, what's half of pi thirds? What? There you go. Pi 6, double the bottom number, and that's good. That's good. 1 mark is pi 6 because what's our shift? pi 6. So that means we're going to shift it right how far? 1 mark. We're going to shift it to the right 1 mark, and that's good. So we don't have to mess with it. So this is 1 pi 6, this is 2 pi 6, this is 3 pi 6, which is pi halves. Right? So we got our marks. All right, so our normal sine, now this is going to go up to 2. We don't have a vertical shift, so that's good. We've already taken care of the 3 with our 2 pi thirds and our period, and then we're going to go to the right one. So a normal sine would be here, up to 2 at the first mark, down to here at the next mark, and back to here. Right? That'd be stretch of 2. Period's already taken care of by our marks. And now all we got to do is shift those over. How far? 1 mark, right? So that's going to go to pi 6. That's going to go to pi thirds. But we don't have to think about it anymore. They're just going 1 mark. So if we get everything labeled good, then, and we do that thing we said with the common denominator, then all of a sudden our marks are there and we just move things over. And hopefully we draw it better. Okay, so, and then that's just 1 period, but we could keep going. This is 2 pi thirds. Each mark is pi 6. This is 4 pi 6, 5 pi 6, 6 pi 6, 7 pi 6, 8 pi 6. Reduce them as you go. Okay, and then you got it. Okay, and then just double check, make sure you got everything. We got the amplitude. Period is taken care of. That's the 3. Shift it over pi 6. Okay, all right. So let's see what else. Okay, so on page 326, go ahead and open up your. I'm not gonna have you get your Chromebooks out right now because you can. It's easy, and I'll just show you there, but just so you can get started here. Okay, so on page 326, the same page we were on before. Okay, 326. I'm just going to talk you through a couple of the different homework sections, and then these are the sections you'll be doing some problems on. Okay, so like on 19 through 26, if you look at that section there, describe the relationship between F and G. Consider amplitude, period, and shifts. So if you look at number 20, so if we were doing number 20, you would say that G is a shift left pi units. That's all you got to do. Okay, 22. How would you compare F to G on 22? G is what compared to F? Horizontal. It's on the inside, so it's horizontal. Horizontal flip, right? So the 3 is in both of them. So we don't have to talk about amplitude or period change. They both have a period of 2 pi thirds, right? So we just want the relationship between the 2. Okay, so it's a horizontal flip of the other one. 24 would be a period change, right? 24 would be a horizontal compression because the period would now be 2 pi thirds. Remember we talked about that 3? That means there'll be 3 cycles for 2 pi instead of 1 cycle in the normal cycle. Okay, so that you're doing that. And then 27 through 30, that section, same thing, except they just give you 2 graphs. So you just say what happened to the black, what did the black graph do, because the other one's just a basic sine curve or a cosine curve, and then what was it? Then you just describe the relationship. Okay, so that's not too bad. And then on 67 through 72, in that section it says use a graphing utility to graph the function, include 2 full periods. Okay, so I'm probably just going to give you a couple of those to just go. I'll put those on the homework and just go on to Desmos, okay, and type those in and play around with like setting the tool. We'll do one here real quick. Okay, and then let's see, the last part you have, like on 73 through that section, they give you a graph, and so you can see where it's been shifted. You can tell what the period is, right? You figure out where 1 cycle is. That tells you what the period is. So then you have to figure out what the equation is. Okay, basically what the A and the D is. Just an amplitude and a vertical shift is all it is. Okay, so it's not a real hard shift. And when you get to 77 and 79, that group, then it's an amplitude, and then that one's a little harder because now it's got a compression in there. So see if you can figure out what those were, and then we'll talk about it tomorrow if you have some questions. Okay, so let me just real quickly. So on Desmos, so if I'm going to type in, here I got several of them here. So let's say number 3. So this is, I think, 67, this is 69. Okay, so let's say I had that. Let's say I only wanted to look at 2 periods of this. Okay, well, somebody tell me what it looks like 1 period. Now, you got the equation, so you can look at the graph, but it'd be better to look here. What is the period on this one? Wouldn't it be 1? Now, this 2 pi is not factored out, so you would have to do that if you want to do the shift. But the period is going to be 1. Okay? So the tools I'm talking about is this little thing right here. And so that's where you can come in here. If the period's going to be 1, what would I want to look at just 2 periods? 0 to 2. So just go 0 to 2. Okay? And the y doesn't really matter. And it is shifted. It looks like there is a shift here and a little bit of a shift up of 1. Okay? But just by figuring out what the period, and then there you would have it. Now, this kind of lands in between here. Okay? So we would have to figure out what this shift is. I kind of picked a bad example, but if I take out that 2 pi out of there, what would that be? If I take out a 2 pi out of this, what's the shift? What do we say you have to do? You have to divide. So it's the pi halves divided by 2 pi, which would be that right there. So what's the shift? 1/4. So I would probably make my markings on my toolbar go by 1/4. Okay? And now look what you got. Now you got this landing right at 1/4. You got this landing right at 3/4. Right? And now you can see those markings. Here'd be your middle, right? Right here'd be your middle right there, that dot right there. Okay? Every 1/4. So by looking at the equation, you can set your markings so everything looks nice. All right. Okay, so I think I wrote. Yeah, so on 73 through 79 odd, I said, so I changed it. I'm not going to add. I told you I was going to add a couple like we just did to put into Desmos. Let's do this. 73 through 79 odd, they give you a picture, and you're supposed to figure out what the equation is. So go ahead and use Desmos. Now, I would try to figure it out without Desmos, and then you can tweak it if it's not looking right, and try to get your picture to match the picture on 73, 75, 77, and 79. Okay, try to figure out the equation, and go ahead and use Desmos to tweak it and see if you... The goal would be to figure out what the equation is, type it in, and boom, just have it. And be right without having to play around. But
Figure out equation and then match it.
because that's what the directions say. The directions say find the A and the D and whatever, which basically means write the equation. Okay? And then type it in. Type it into Desmos and see. Okay, now am I going to know if you type it into Desmos? No, but if you're wrong, then... And they're odd, so you can check, but I mean, that would be a last resort. I would rather, instead of you check it in the back, check it with Desmos. You're going to learn more about moving these graphs if you do it that way. So the ones you have to graph by hand are those 5 there, 45, 49, 51, 57, 59. Those are, you have 5 graphs you got to try to do by hand. Okay, where all that work we did with getting the right marks and everything, that's those problems. The 19 through 29 odd is just describe the shift. So those don't take very long.